has
So I think sir, 10:15 to
11:15 కి క్లోజ్ చేస్తారు. మధ్యాహ్నం ఇంక పెట్టకండి అయితే.
ఓకే సార్. మధ్యాహ్నం మరి పెట్టండి
సార్. సెషన్ విల్ బి ఫ్రమ్ to 1:30. So don't
okay.
put any sections after 1:30.
Okay sir. Okay sir.
For
Okay,
today, everybody, all the students, please go by this way, this schedule. Please join the 7:15. and join here for the DVP program at 11:15. And then the session DVP lectures will be till 1:30, and there will be no afternoon session for today. Hope it is clear. Anybody?
Will be same.
No, this is for today. I will announce the situation of the schedules of tomorrow during the session today. Okay?
Okay, sir.
Okay. Yes, everybody, please join the class. All the third year students, you are requested to join. The class will be till 11:15, and then we'll start the DVP lectures at 11:15. 11:15 to 1:30, and there will be no afternoon session today. So sorry for extremely for the inconvenience caused. There was some technical our resource person. I request all of you to cooperate with this. Join the class till 11:15, and then switch over to this session once again at 11:15 till 1:30. Okay, in the afternoon we have questions in the classroom. Okay.
వేస్ట్ అయి ఉంటది మామూలుగా స్కాపర్స్ పేపర్ అంటేనే నాకు ఉంటుంది మేడం మరి 10 కి 15 వస్తుంది.
Yes, once again, everybody please make a note. Please make a note. Yes, everybody. Please, the DEP lectures are rescheduled to 11:30 to 1:30. The DVP lectures for today are rescheduled to 30 to 1:30, considering the technical problems at the resource person end. I request everybody to join the session again at 11:30 till 1:30. The classwork for the third year ECE students in the afternoon is cancelled. Now they can straight go to the work. I request once again everybody to note the session now due to for today. I request everybody to join the session at 11 once again. And I request everybody to join 5 to 10 minutes prior to the session.
গ্রুপ হচ্ছে কশি গ্রুপ আমার সাথে কষে কিছু
What you said?
I will introduce
Oh,
for a minute.
okay.
Yeah.
Everybody knows me.
Yes, yes, especially in this college. You.
Yes.
But there are have joined from outside this organization, and few
Correct.
people have joined this organization recently. So at least for them, I think I need to introduce. It's
Okay.
my honor once again to. But a warm welcome to this three, which is a part of professor lectures, which is completely sponsored by Indian Academy of Engineering, by Department of Electronic Communication, Raghu Institute of Technology, in association branch and the Communication and Signal Processing Society student chapter in IEEE student branch of Raghu Institute of Technology. This DVP has been sanctioned last year, and with the contributions of Ganapati, this opportunity to organize this DVP since last year. Earlier in the last year, 2019, we have organized this for two sessions, 3-day sessions, one in the even semester and the other one in the odd semester. And we are very lucky that, or fortunate that have received the extension of this DVP INAE. And I have to actually mention the support extended by Professor Ganapati Panda sir in this regard, especially in DVP for this academic year as well as academic year also. So in this is the as per the advices from INAE, we are doing this online. Maybe the next semester or at least the next year we'll be doing it live once again. What anyhow this online cannot be a barrier. You saw in contact. Uh, uh, so, so I request everybody to join for session. And as mentioned, there is a small change in the timings. From earlier, it was from we have 12 in the noon. However, we have rescheduled from 11:30 to in the afternoon. So kindly note this point and join accordingly. Now let me take the privilege of Ganapati Panda sir. New to any of the Raghu Institute, maybe a faculty or maybe a student, especially fraternity of Electronics and Communication in the Raghu Institute of Technology. However, we have many new faces who have joined RIT in the form of second year students or in the form of new faculty. So for them again, I would like to take the privilege of introducing him. Professor Ganapati Panda sir is currently a professor and research advisor at CV Raman Global University, Bhubaneswar, India. He is the former Deputy Director, Dean Academic Affairs and Head School of Electrical Science at Indian Institute of Technology, Bhubaneswar. He was also Dean Administration Head of ECE at NIT Rourkela, Member of Board of Governors of Bhubaneswar and NIT Rourkela. He also served as Director of National Institute of Technology, Jamshedpur. He worked for 47 years in teaching and research in leading technical institutions in India. He did his postdoctoral research work at the University of UK during 1984 to 86 and PhD in 1981 from IIT Kharagpur digital signal processing. He has guided 42 PhDs in the field of signal processing, communication, AI, intelligence, and machine learning. Published more than 380 research journals and conferences, 53 far, and with a H and I-10 in and 6 more PhD students their PhD work under his active guidance. He is a fellow of National Academy of Engineers India (FNAE) and fellow of National Academy of Sciences (FNASC). Significant research contributions to signal processing and machine learning. He has received some Sekhar Award in Patna 2012, INAE Outstanding Teacher 20, AIC Professorship in 2000, and of it, thank you very much. AICT Margadarshak in 2000. He is a senior member of IET, fellow of IE, life member of CSI, life member of IST, and life member of System Society. Thank you very much, sir.
Yes.
Again, a warm welcome to you. This is a this 3-day workshop as a part of DVP from sponsored by INAE as Prof discussing on that starting from artificial neural networks to biological neural and variants of it and few quoting few. So this will be definitely beneficial to all the research pursuing candidates in the college, in the department, and also to all the who are listening to you, who are working towards their projects also. So thank you very much, sir. Over to you.
Yeah.
Yes, sir.
Should I start now?
Yes, sir.
Good. But before I start, just a clarification from you. Yes. Hello.
Yes, sir. It's visible,
Yeah.
sir.
Just one point. The many students are also there. In my first lecture today, I'll give an overview of about at least two of the techniques I'll be speaking. So today's lecture is only fundamental. Only I'll give an overview of artificial neural network. And if time permits, I'll go to details of at least one or two techniques. But tomorrow and day after, one day will be completely on deep learning. At least 2 to 3 types of deep learning I'll cover in details. But tomorrow maybe some of the new type of artificial neural network, which usually do not work, on that I'll be giving my lecture. So this is what I want to tell. Is it okay, Professor Chakravarti? Is it okay?
Yes, sir. Absolutely okay, sir. Absolutely okay, sir.
Okay, take it. So now I'm loading my slides.
Yes.
Yes. Start. Okay. Hello, good day to all of you, all the participants. Before, is it visible?
Yes, sir. Visible.
Is the slides visible? Just.
Yes, sir. Visible.
Okay, is it visible?
Yes, sir. Visible. Also,
Okay.
sir, if possible.
Okay. So, thanks to Professor Chakravarti, thanks to Professor Principal Satish Chaudhary and others who has given me the opportunity to interact with all the participants who are present today. We decided that during these 3 days, we'll go in depth up to artificial neural network. I have done a lot of work in this field. Many varieties people do not know or aware of that. I'll give an overview of that. And those who will be interested to learn more on any of these techniques, I'll be in a position to help them separately, individually go to the details. This lecture program of 3 days, this lecture program of 3 days, this lecture is is because of the college, Raghu College Institute of and program. Listen for about 1 hour 30 minutes. Just I'll give what are the different. Basically, the human brain consists of actual neurons. In the neurons means it is a small computing biologically active neuron. They are called biological neuron. In the neurons are connected in layers. In each of the layers, weights are not fixed. Depending upon the type of problem we solve in the brain, the weights are adjusted. The weights varies from a very small value to a high value until whatever we need to get from out of the brain, we recognize, it. We say, we remember certain things, we forecast something, we classify something, we cluster something, we remember multiplication table. Everything is done by this artificial neural network. Artificial neural network is the model of the actual function in the. We have got biological neural network and artificial neural network is the model of that. Today, I will tell that there are so many types of artificial neural. Usually, we know the back propagation, multi-layer perceptron type of network, but that is only one, a oldest one. What are the recent development? What are the recent improvement in the artificial neural network? That I will tell. Artificial neural network is a massively parallel distributed system. Even if some of the neurons are disconnected, still the network works. It is a robust system. Signal passes through other network because they are all interconnected. Somebody is slow in learning. Somebody is fast in learning. Somebody is forgetful. Somebody learns once but learns forever. Somebody is erratic. Somebody is cool. Somebody is short-tempered. Somebody behaves in a different way. All this can be studied by studying the network of neurons which is there in the brain. We are models. There are more than 20 types of models. Models are only model only. It is artificial model. They map to the real model of the brain. Now the brain science has become very, very important. The behavior of the person. If somebody is short-tempered, cool, a slow learner, can you fast learner? Somebody is mathematics, can that person? Yes. These types of studies can be. If you know more details, artificial neural network. With this little background, let me start. What are the types of artificial neural network that exist? One is very standard and old feed-forward neural network. Feed-forward neural network. This is also called multi-layer perceptron, MLP. These types of network, you see in the diagram, a small diagram, input is 3. They are not neuron, they are just the input. When you see a pen, when you see an animal, when you see a car, or when you give some input, that input propagates from the 3 point. Here it is 3. Input can be 1, input can be 100, input can be 1000. The middle one, they are not actually the input one is neuron. The middle one, 4 are there. So they are artificial neuron. What the artificial neuron does, they multiple weights or the coefficient, add them, pass through a nonlinear function called sigmoid function, known as activation function, and produce the output. And that output of the hidden unit again pass to the output. That is from hidden to output. There are connecting ways. The output is
Sir,
sequence.
screen not visible, sir.
Yes.
Screen not visible, sir. We are able to
Screen
see
is
only
not
the first
visible.
slide.
Just a minute. Screen
Not
is
shared.
Here,
Your
1 minute.
presentation is not shared.
Okay, I'll just. Is it visible?
The first slide is visible, sir. Can you go to the next slide so that I can see the change over the slide?
Visible? Hello.
The presentation mode.
Is it visible?
Sir, can you
This
change
slide.
the slide? Can
Not
you,
visible? Hello?
sir, the first slide is visible.
Okay, this slide is not visible.
Not visible. The presentation mode is not shared. The
First slide is
PPT
visible.
shared.
Visible. Just a
Mode is
this is visible.
the screen you
No,
entire
it
screen,
is
sir.
in artificial neural network, Professor Ganapati Panda.
Yes, sir. That is visible now.
Okay. This one,
Go to next slide, sir.
types of, next slide, types of neural network architecture.
Not
Not visible?
not visible, sir. You screen, sir. Entire screen, entire desktop.
This is not visible to you.
Yeah.
Is it visible? First slide.
Visible.
Okay, next one. Is it visible? Hello?
No, sir. No, sir.
Hmm?
No, sir.
This one not visible?
No, sir.
The first one is visible. The same slide
Now
set.
it is visible. Yeah, now it is visible. Second
This is
slide.
visible now? Huh? But this is
Types of neural network architecture.
yeah, this is visible.
Yes, sir. Feed forward neural network.
Okay, okay, okay. So sorry, a lot of disturbance. So this is visible.
Yes, sir.
Okay.
Visible.
So I was talking about this one.
Yes.
Feed forward. This is simple standard artificial neural network, multi-layer perception, or this is generalized artificial neural network. We give an input, the input is multiplied with the weights between the input and hidden layer. We add the bias, output of the hidden layer neuron is multiplied with weight, and then again add the bias and produce the output. Now, in a supervised learning, the output is compared with the desired signal or the training signal or the testing pattern. It is a supervised learning. And by comparing, you get an error. That error is used to update the weights between hidden layer and the output layer, and the weights between input layer and the hidden layer. Again we give the input, produce the output, again compare with the desired signal, produce an error, used to connect multiplying coefficient between input layer and hidden to output layer. This process continues until the network is trained. How to know the network is trained? The output and the desired signal or desired value must match. If you are putting the figure of a cat at the input of the neural network, the output also produces the cat. In that case, error is zero or error is minimized. Square of the error is an indicator that whether the network has been trained or not. This is the basic principle of supervised learning. But there are many types of networks are available. This is the first type I told, backpropagation based artificial neural network NLP. The second one is recurrent neural network. Many people must have used this. It is called RNN, recurrent. You see here, similar to backpropagation, but here in the 4 neurons are in the second layer. If you go to the first neuron, the output of the neuron is fed back to the third one. The output of the first one is fed back to the second one. The output of the first one goes to second and third. Now, similarly, the output of the last one comes to the second one. From the second one, the output goes to the first one, goes to the second one. From second one it goes to the third one. So they are all interconnected, and this is recurrent, because what is called recurrent is just like a feedback connection. So that means the output you take, no doubt, but the output is fed back to another unit in a sequential manner. And these types of network varieties are there. That is, it is just like an IIR filter, and this works better. But it has some problem, that part we'll discuss. In our human brain, they are more biological realistic. Our biological neurons are similar to recurrent neural network. Recurrent neural network are very important types of network where there is a feedback connection. In case of feed-forward network, there is no feedback connection. This is what I wanted to tell. Okay. Next, if you look, symmetrically connected network. This is the third type, symmetrically network. There are also recurrent networks, but the connections are not random. Connections are symmetrically, and one of the examples of symmetrically connected network, many people might have used HOPFILD. John Hopfield made this recurrent network in a symmetric manner, looks similar, and this is did because these types of network can be analyzed better. These types of network perform in a regular fashion. Therefore, one of the recurrent network which are symmetrically connected is known as Hopfield net. Okay. Let's see. These are called, this is another one, Boltzmann machine. This is also symmetrically connected. The previous one is a Hopfield net. This is another type of neural network, Boltzmann machine. These Boltzmann machine today are used for deep learning. Boltzmann machine are very powerful model, better than Hopfield net. They are less powerful than recurrent neural network. They have a beautifully simple learning algorithm. Well, I teach this in later on about the symmetrically connected networks. So basically what I said, I talked about recurrent neural network. That is, what is recurrent? That is, the output of a neuron is connected to other neurons. One layer that may happen in many hidden layers. So this is an overview of the recurrent neural networks. Now let us see the recent generation of neural networks. But before that, I want to tell you, before that, there is a functional link artificial neural network. There is another network called radial basis function neural network. They are conventional, RBF and functional link artificial neural. If people do not know, they want to know details about these two types of network, tomorrow I can teach. Yes. So recurrent generation of neural, recent generation are very, very interesting. Let's see what are these types of artificial neural network. Now this network, one of the network is spiking neural network. Spiking neural network, I am seeing my blackboard. There are 5 types. I am working on this spiking neural. Remember, in all types of neural network, connecting weights are used. Weights are adjusted. Weights are updated by some algorithm. Weights means a magnitude between 2 neurons which is adjustable, which are updated according to some learning algorithm. But in case of spiking neural network, they are not weights. They are the distance between 2 spikes. In actual brain, in our actual biological neuron, the output of the neurons are spikes. Spikes means impulsive noise. Impulse, just like an impulse, sudden rise of the signal. It time. So the distance between spikes that is generated is similar to the weights because the distance doesn't remain constant. For some problem, for some picture, the neurons between 2 spikes are very small, but in some other case, the distance between 2 spikes are large. So that variation of the distance between spikes is similar to the variation of the weights. Today, spiking neural network has gained the momentum. Those who want to do research work or want to learn more, it is possible. They have their own learning algorithm. Spiking neural network is so important. They actually study the brain, how occur, how to cure can be studied, can be understood that spiking neuron. It is the actual activities of the brain. So try. I have told two things. Somebody, students are there, you can. I first told about one neural network. Then I told about, we call it multi-layer perceptron. The next one, I told about Hopfield net under recurrent neural network. So you can say recurrent neural network under that Hopfield net. And yes, and there are other types of network are also available under recurrent case like LSTM, etc., which are found. Now, out of the modern architecture, most important one is the spiking neural network. To my knowledge, there are 5 types of architecture so far. Till today, it has been published. So SNN, those who want to do research or want to work on this, you can work on the spiking neural network. If you look to this picture, yes, you see there are a lot of impulsive signal and the distance are not same. So they represent the weights. You pass this signal, do some types of operation, vary the weights, means vary the time between two impulses and produce some desired output. So spiking neural network is very important. Neural network and gaining lot of importance in the for cure of the, for better forecasting, for better important neural network. Let's see the, I was talking about spiking neural network. Now let's see about deep learning. So basically what I said, Hopfield net, recurrent neural network, spiking neural network. There are so many deep learning models. They are also artificial neural network. Let us try to learn about some of the deep learning models. What are deep learning models? They are more than one hidden layer. More than one hidden layer. Deep means number of layers are more. So if the number of layers are more, what is the purpose of it? Basically, the deep learning, the most of the layers are used for feature extraction from the given set of data or picture or video. Instead of conventional method of feature extraction, the model itself performs the feature, finds the feature, and in last 1 or 2 layers, these features are used for prediction or classification or detection purpose. So this is very important today, deep learning model. Now deep learning model, there are many types, but today if you see a small picture I have given, that as the amount of data is increasing, as the amount of data is increasing, the performance of the deep learning and the older type of learning, you can see the performance of deep learning increases. So please remember that deep learning is suitable for large amount of data, for analysis of big data, finance data, pollution data, manufacturing data, so healthcare data, where the amount of data is more, people has to use deep learning method. I have shown in the first diagram only one hidden layer. Car to be recognized as car. So basically you have to extract the feature. First one is feature extraction, then you do the classification by using neural network. But if you are using deep learning, the second diagram, deep learning, that the object, number of hidden layers are more in the all the yes, the feature of the are extracted. Features are used in the last to make a classification or forecasting or any types of operation. So that way it is very important. Now various types of deep learning models are available today. Various types of deep learning models are available. I'll give an example of some of the models. Yes, please see. Recurrent neural network. This I have already told you. That is, the output is again feedback to the input, just like an IR filter. These types of things reimburse the memory, the old data, and performs better. But it has some problem. So basically, RNN is a feed-forward feedback type of network, is better than feed-forward network. Let's see. Is the slides visible? Is it visible?
Yes, sir. Visible, sir. Recurrent neural network, RNN.
I am only giving an overview. I'll go to details. Whatever you say, I'll teach in details. Recurrent neural network, RNN. You see, this recurrent neural network, I is the input cell, O is the output, and R, hidden layers, two layers are there. They are recurrent cell. Means the output, there is a feedback path, that is the output is feedback to the type different, and this is nothing we can say is a distributed IR filter system, non-linear IR filter system. I call it in that way. That is the RNN. Now let's see recurrent neural network. If a recurrent network performs better than the conventional backpropagation network. These types of network do time series prediction, speech recognition, rhythm learning, anomaly detection. Many types of applications are there, but they have some limitation. These types of recurrent neural network are having a problem of gradient becomes zero. So the network doesn't learn. So that is called vanishing gradient problem. Vanishing gradient problem means the derivative doesn't exist, becomes zero. Therefore, the weights, connecting weights are not adjusted. Therefore, it falls to local minima. You do not get the perfect solution. So this is one of the very, very important. Recurrent neural network is certainly good, but it has some associated problem which needs to be solved. And that problem is called vanishing gradient. Now, if you look to architecture is very important, long short-term memory. In short, we call it LSTM, long short-term memory. LSTM network that have a memory cell, it has a memory. Remember the past, therefore it performs better. And LSTM is a type of RNN. LSTM, if you want more details about that, I can teach. So if RNN fails when we have a large number of relevant data, we have large number of data, RNN doesn't work. And now we want to find out the relevant data from it. Then LSTM is preferable. LSTM can remember data from a long time ago. So it has the memory cell, which is not present in in case of your RNN. Please see, this is a simple diagram, long short-term memory. That is, here if you look, the hidden layers are memory cell that is different from RNN hidden layer. Feedback is there, but there is you see there are two, and this represents memory. So memory built in the neuron. As if feedback is there and memory is there in each neuron, hidden neuron, that is we call LSTM network. LSTM network is different from RNN in the sense that in case of RNN, memory is not there. So past information are not remembered by the network. Whereas in case of LSTM, the hidden layers are memory layer. So basically they have a memory cell. And this not only memory cell, there is a feedback from code and that resultant network we call is long short-term memory. Long memory as well as short-term memory. And it has a lot of advantage today. People have been using the long short-term memory. Okay. The long short-term memory network, LSTM, is used for speech, a lot of speech recognition, writing recognition, that is for natural language processing, major applications of LSTM. But this has some problem, as I told. LSTM suffers from vanishing gradient. What is vanishing gradient? As the number of layers increases, the derivative of the mean square error which you are computing becomes zero. When the gradient becomes zero, the weights, connecting weights are not updated. When the connecting weights are not updated, then training doesn't become perfect. And that is the greatest drawback because of many connected hidden layers. So this is called vanishing gradient problem. Instead of weights are to be optimized, the weights are frozen at some value which are not correct. And this is available in RNN and LSTM problem. So this is long short term, and therefore various types of development and improvement has come. Please see, many people might not have worked in modern. This is a deep network. DBN today is very, very powerful algorithm. It is a powerful network. Deep means many layers, and that network is belief network. It contains many hidden layers. We call it DBN with an unsupervised algorithm. It is not a supervised algorithm. As it first launched without any supervision, deep belief network can train itself without any desired signal, without any supervision. The layers in a DBN acts like a feature detector. The most of the initial layer of DBN is a feature detector. They detect the feature. After unsupervised training, we can train our model with supervised method. Initially, unsupervised training, extract the feature, and after the features are extracted, they are connected with the classification model, yes, which works in a supervised method, either for classification or prediction. Today, we must learn deep belief network, which is a very powerful artificial neural network. Deep, as I told, I'm giving an overview. I'm not going to the details of this deep belief network. Let's see the next one. This is the architecture of the deep belief network. So basically, you have got input cell, hidden cell, this double circle, the smaller one, 2 in each case. Then you have got hidden cell, 4 in each case. So the two types, one is hidden layer, another is only hidden layer. And then you get the supervised one, either supervised artificial. So this is the simple architecture, a deep billing network which is popular and doing a lot of research on this deep billing network. Deep billing network uses hidden layers. They are robust for classification. Application retrieval, documents and images, they are used for non-linear dimensionality. If want to feature reduction, people are using deep billing network. They reduce the number of features, but it has some limitation. Computational cost is high. That is step towards further optimization in the network based on maximum likelihood training. Hardware limitation is there for implementing, for doing hardware implementation because of feedback structure and because of a lot of interconnection. So it is hardware, it is more costly. But still, deep billing network is very, very popular network. Is next one. Convolution neural network, CNN. Convolution neural network. Most of you must have used. It is very important, very simple, full. Convolution. Why it is called convolution? Because you have to perform in many layers convolution. Convolution is usually performed between two sequences, you know. One is filter sequence, other is input sequence. And the input and the filter sequence are convolution operation you do, basically nothing but filtering. Filtering means input sequence and the weight sequence of the filter are shifted and multiplied, and that is nothing but linear convolution. Linear convolution is a software method of filtering. And by performing convolution, the features are extracted as you are trying to remove the unwanted information and extracting only the required thing. Because it is a filtering operation. It removes, it extracts the juice of the signal, removes the noisy component, and many layers you perform the convolution. Today, this convolution neural network is one of the first kind of artificial neural network which are called deep learning neural network and has gone and is very popular and powerful. Of course, many modifications of the CNN has been reported in the literature. Okay. Hello, Professor Chakrabarti, are you able to? Is it okay?
Yes, sir. Everything is okay, sir. Everything is audible, pretty much clear. Good.
Not visible.
Audible, sir.
And it's not visible. The slides are not visible.
Visible, visible.
Okay. Should I
Visible.
continue?
Yes, sir.
Okay.
Yes, sir.
Yes.
We can continue.
Okay. See, the convolution neural network, CNN, the architecture of that. Yes. Convolution neural network. Please see, there is a picture here, and that picture is to be recognized. You have to classify whether it is a car or a truck or a bus or a bag. So for that, once there is an object, or an image, usually conventional neural network extract the features, and the features are used for classification. But in this case, we from the object we do not perform. We just take the pixel value and perform convolution. There is a so the filter is moved to and the window picture is convolved with the and the is moved from left to right and from then top to bottom to cover the whole picture, and the corresponding convolution takes place. And after the convolution, you are using pooling. What is pooling? Pooling we are using to reduce the size. There are two types of pooling. One is a max pooling, other is average pooling. In case of max pooling, you take the maximum of the window value. If there are 9 values, of the 9, all other 8. So it is used for data dimension reduction without sacrificing the quality of the data. And in case of average pooling, you take the average of all the 9 points and replace that window by only one value. So there is a reduction vis-a-vis. There is no reduction in the quality, but reduction in the dimension. This is only one stage. You repeat the number of stages. Again convolution with another filter. Again pooling. Then convolution, then pooling. And after that, in the two-dimensional data, after you obtain, convert to one dimension. And then you perform the classification or forecasting, depending upon the requirement. Basically what I'm saying, the CNN, the first few sets of layers are dedicated for feature extraction, and last couple of layers of neural network for classification or prediction. You can use simple CNN, or you can use support vector machine, net-based, random forest, or any types of classifier to perform well. So basically convolution operation is for feature extraction, and neural network in the are used for classification or forecast. This is what I told about CNN. Okay. Can I give a gap for just half a minute? Just half a minute gap, please.
Yes, sir. Yes, sir. We'll take a break for 5 minutes.
Yes. Professor Chakravarti, if people want 4 or 5 minutes gap also I can give.
Sir, you give a break for 5 minutes, sir?
I'll continue or will give gap for some time.
Yes, sir. 5 minutes.
Gap will be okay? Okay,
Good,
so
sir.
I request all the participants, they will give gap for 5 minutes, and after that again I will start a very important one, GAN, Generative Adversarial Network. Okay?
Yes, sir.
Okay, thank you.
So I request all the participants to be in the room. We will take a break for 5 and after this 5 minutes, the lecture will continue. Thank you. As I mentioned, after tomorrow also, the lectures will be from 11:30 to 1:30. As mentioned, today it's a completely an introduction to all the different types of neural network architectures. Tomorrow, discussion on few other applications related to these neural networks will be discussed. People who are working on this, they are open for discussion, and you can this to put the research problem, get involved in discussion with our Panda sir, and you can problem solved if you are stuck at any point. And besides this, also, sir is available or open to discuss on how to write research paper, how to write a research proposal also. If you have any potential query on that, you put that in the chat window or put directly, you can directly contact Chaudhary sir and put your query so that it will be conveyed to him and it will be discussed in the next session. So this DVP is entirely to make it possible to the professors of IIT, and we are very that we have Professor Nasar, who is almost known as stalwart of advancements in signal in India. Meanwhile, I also suggest the students come out with any ideas or any particular topic to be discussed today itself, so that I can put that in front of Panda, convince him to discuss on those topics. We have all these 3 days, and we have earlier also we had a very good experience with him. Know how he deals with the students. So yeah, we all wish to sit in IIT listening to professors. However, through P, fortunate the IIT professor himself is in front of us to teach some latest which are very much useful for your research or your projects and for your career also. As mentioned, not only technical discussion, but also the floor is open for discussions on research paper writing, proposal, many other things, whatever, PhD guidance also. He is here to assist all the PhD pursuing candidates as well as project pursuing candidates. So I request everybody to make use of it. Thank you. Sir, we have faculty members who have recently joined.
Yeah. So,
Yeah.
yes, I request all participants to join again. This is, many people might have used very powerful artificial neural network, comes under deep learning model, generative adversarial network, GAN. There are two networks here. One is a generator, another is adversarial. Choose this GAN. If your number of patterns, number of learning patterns are less, when you use this, that if the classification problem, one number of patterns, class 1 patterns are more, class 2 patterns are less, unbalanced data. What is unbalanced data? There are two classes, but in one class more number of data is available. For other class, the number of data are less. This is called unbalance. Either it is less number of patterns, you can create, GAN can create more number of patterns. GAN can generator generates more pattern, similar pattern. Suppose you have got only 30 patterns to train, but 30 patterns are not sufficient. You have to generate 100. So, and GAN can automatically generate the input patterns or features. GAN adversarial network today is a very powerful network. Given a training data, GAN learns to generate new data. From a few set of data, new data can be generated, which has the probability or statistical distribution similar to the original data. They have got a probabilistic or a statistical features, they are same. The objective of the GAN is to distinguish between real and synthetic result. One is a real result, real data we are having. Other is artificially you are creating the data. And the output of this, using real data, the output of the model, and from the generator, using random noise. You are using only random noise to the second model, generator model. It doesn't take the actual input. It takes the random input, produce the same pattern or image or features as that of the actual one. You compare it. If it is not matching, you try to update the generator parameters, try to update the generator until the output of the adversarial network output matches to that of the generator one. Until the matching is done, the training process continues. I am giving even a picture to show that the generative adversarial network, basically you are giving a known picture to extractor. Simple, because you know the picture, you get a. Now, the generator network will try to output. That is, generator network which in not this picture, the noise, random noise. And with that noise, it will produce a similar output. It cannot be 100% similar, but that is almost duplicate of the actual image. You make a comparison, and if the comparison error is there, the generator try to improve. By this process, you produce more number of patterns, and these patterns are used for classification or forecasting. Today, the GAN is a very powerful deep learning network where it is applicable is if the number of features are less or the data is unbalanced and number of features or number of data set is less. So you can use this GAN network. Full form is generative adversarial network. In short, we call it GAN. GAN you must learn if you want little more details that one should practice. And today, most all of the people who are working research, they are trying to use GAN. In a recent of our work, we have used GAN for COVID detection. GAN is being used. We are using for heart disease detection, pneumonia detection problem. It's very powerful and important. There is another important artificial neural network. It is a deep learning network and it is called autoencoder, AE in short form. What is an autoencoder? It is a neural network. It is a unsupervised machine. It doesn't require any desired signal. Whatever input you are giving to the neural network, you give the same output as your desired signal. You are giving an image, at the output also you apply the same image. Input and output are same. Whatever error you are getting, the actual model output, encoder output, and the desired same input you are giving. You are giving a suppose picture of a cat. The model will try to produce a picture of the cat. And if the cat picture is not matching, you get some error. You are applying the same cat picture at the output as a supervised mode. You got error. Update the weights of the autoencoder. It is just a simple neural network until the input becomes equal to output. The input is a cat, output should be a cat. Input is an elephant, output should be an elephant. And once you train the autoencoder, the number of hidden units are kept very, very small. If the input is 1000, the hidden unit is 20. So there is a reduction from 1000 to 20. And this 20 is called the compressed signal. It's called the compressed data of the actual input. And this compressed data, if you put to a model, taken in the picture of the donkey can be reconstructed. So it is used for feature reduction, it is used for dimensionality reduction, it is used for making the processor faster, making the process cheaper, and accuracy-wise it is same. Autoencoder, the hidden layers, you take the output, it is a compressed data. If there are 10,000 data you are using as input, the compressed data may be 100. And from this 10,000 or 1,000 to 100 is called encoder. And from 100 back to 10,000 or 1,000 is called decoder. So it is a encoder-decoder mechanism. But the hidden layer unit should be less. And this is very powerful and are used today as one of the deep learning method. It is used for different types of autoencoder. Only 2, 4 is reduced to 2. So this 2 is called reduction in dimensionality. They are called reduced feature. And reduced feature is used as input. A model can reconstruct the same thing. A compressor expander. Input to hidden is called compressor. Hidden to output is called expander. Autoencoder is very, very interesting machine learning, particularly deep learning, artificial neural network, autoencoder. Autoencoders is a smaller representation of the input. It is used for classification, clustering, feature comparison. Autoencoders are not that efficient as compared to GAN. GAN is much better. So autoencoder is still very simple for reduce an image, and from reduced image you can able to reconstruct it. It is used for many applications, no doubt, but the reproduced image becomes blurry. It doesn't become as good as qualitative as your which one again. But autoencoder is still very powerful and people are using this GAN. So far, what I have talked, so far I am just repeating. Perhaps I started with backpropagation, multilayer perceptor. Of course, I did not explain in that category. You have got a radial basis function, where Gaussian function is there in the hidden layer. You have got functional expansion neural network, trigonometric expansion, Chebyshev expansion, and other types of expansion, power series expansion are there. This is single layer model. So basically in conventional neural network, perceptron, radial basis function, and you have got functional being artificial neural network. Then I told about the recurrent neural network, where there is a feedback mechanism. And one of the special type of recurrent neural network is special type of recurrent is LSTM. Then I talked something on HuffNet. I talk on HuffNet. Then I talk on deep belief network, HuffNet, deep belief network. Then I talk, something like spiking neural network. I don't know whether autoencoder I talked. I got deep belief network. I talked on GAN. So these are the various types of artificial neural network. Most of the latest neural network are very powerful, use as deep learner. The Boltzmann machine is an old network model. A deep Boltzmann BBM is very powerful. Boltzmann machine involves the probability distribution. Given an input data set, we have an input data set. It has a particular probability, whether Gaussian, uniform, or relay. You get first to draw the distribution. Now, in Boltzmann machine, the input nodes and hidden nodes are present. As soon as you keep the hidden nodes, change its state. Input nodes transfer the output node such that the probability distribution becomes. If you can able to achieve the Boltzmann machine to produce output, that is the reduction it is used for regression or prediction, collaborative filtering, and feature learn. Boltzmann machine, and particularly today, deep Boltzmann machine are very powerful. That is one interesting thing which I am telling. So Boltzmann machine is also very interesting. Let's see. This is a diagram of the Boltzmann machine. So you have got backfed input cell. The eyes are the input cell, but they are fed back again, backfed. And the probabilistic, the HR, the hidden cell, and their states are changed in such a way that the input data set probabilistic pattern and the probabilistic pattern at the output remain same. If you can able to do that, then the Boltzmann machine produces reduced data. It produces classification performance. It produces forecasting performance and are very helpful for many application areas. Boltzmann machine today, deep Boltzmann machine are being used by researchers for healthcare problem, for finance problem, for many types of machine learning problem, for analysis. This is about Boltzmann machine. Next, this is Kohenon network, KN, Kohenon network. This is a unsupervised loop. You do not have to give the desired signal at the output for the network to train. It is unsupervised. Kohenon network is also a self-organizing map. It automatically organizes itself, self-organizing maps, which is very useful when we have our data scattered in many dimensions. Data is scattered in many dimensions, and we want to reduce the dimension like two-dimensional data. So it is mostly used for feature reduction. It is mostly used for data dimension reduction. The Kohenon network, for visualizing high-dimensional data, you reduce to two dimensions or three dimensions. Application, dimensionality reduction, assessment and prediction of, just I have given one paper, I have said water quality. It is used for coastal water management, but it can be used for any types of dimensionality reduction. Why you have to reduce the dimension? Dimension is reduced to make the processor simpler without sacrificing much of quality. Dimensionality reduction, we are used to faster training. We are used to make the processor simplicity, keeping the accuracy almost constant. And Kohenon network, please remember, and is used for feature reduction or data reduction. Kohenon network is very, very interesting network. Not used, they can. This is the architecture of the Kohenon network. You are giving the input, there are hidden units. Please see, unlike artificial neural network, all the hidden layers inputs are not connected to all the hidden layer output of the next layer. Input is connected to the first hidden layers. Input is connected to second as well as third. But from second to third is not there. From third to fourth is not connection is there. Only input, everywhere is connected here. So this is a new types of architecture I have marked. That is from output of the second doesn't go to the output of the next layer. But from the input, it goes to the other layers. So this is Kohenon network. Yes. Types of neural network. It is called deep neural network. Deconvolution. We first layer CNN convolution neural network, but it is deconvolution neural network. If X is convolved with H, we produce Y. Y is the convolution of X sequence and H sequence. But if I know X and H, I can produce Y. But if I know Y, what is known, and out of X and H, only X is known. If X is known, Y is known, I can find out H. Y is known, I can find X. This is a deconvolution operation. I can of deconvolution, hundreds of examples. When an earthquake occurs, you are getting the response in the earth's surface. But that is not the actual strength of the earthquake. You measure actually Y. The actual earthquake strength is X, which takes place in the epicenter. So from Y, which you are seeing in the instrument, you have to find out the strength of the earthquake by computing X. So from Y, if you want to compute the X, that is called. So deconvolution neural network is similar to conventional neural network, but instead of convolution operation, you perform the deconvolution. The DN may lose a signal due to having been convolved with other signal. Even though the DN is similar to CNN, its applications is different. Application areas, super resolution of an image. You want to enhance the quality of the image, you have to use DN. Surface depth estimation from an image, optical flow estimation. So it is used for enhancement work. It is used for higher resolution. It is used for achieving better accuracy. Deconvolution neural network, if you have not worked, please try to learn about the deconvolution neural network. This is, please see, the architecture of deconvolution neural network. The architecture of deconvolution neural network. Input is 2, output is maybe 4, 5, 6, depending upon the requirement. I is input cell, K is called the kernel, the vector, C is the convolution or pool, O is the output cell. So it comes from the output to the input side. It performs deconvolution. I know input, I don't know the input, but I know the output. I have to reconstruct the input side. So it is similar process, but it is a backward process, deconvolution operation. There is another types of artificial neural network, which is very powerful. Extreme learning machine, ELM. Extreme learning machine. ELM randomly chooses hidden nodes. It chooses randomly the hidden nodes, not all are connected, and then analytically determine the output weight. The output weights are from the last but one layer to the output layer. Therefore, these algorithms work way faster than the general neural network. General neural network, all weights are interconnected. But here, actually the weights which are interconnected, which are updated, is only at the output layers. It is an extreme learning machine network, randomly assign the weight, which are not the input layers, which those weights only the layer is updated. And therefore it is much faster. Application classification. It is used for forecasting of the clustering and feature and many such purpose. Neural network is very, very interesting, very powerful also. ELM, extreme learning machine. Please see the architecture of the ELM. So architecture of the ELM. You have input 3, output 2. There are many hidden layers. But in case of your conventional network, all units are interconnected to each other. Not within the layer, but outside there. But here, there is a random connection. Some things are dropped. All weights are not connected. Finally, only last layer, 4 into 2, instead of 8, only 5 are connected. Between hidden to last but one there, 4 into 4, there should be 16 weight, but hardly there is 1, 2 weights. No, after 16, others are dropped. So there is a massive reduction of the connecting weights. But this not only saves the overfitting problem, also performs better. But random, you are dropping randomly these weights. There is another type of network, eco-state network, eco-state. The eco-state network is a subtype of recurrent neural network. It is a subset of recurrent neural network. Here each input node receives a nonlinear signal. Each input node receives a signal. In ESN, the hidden nodes are sparsely connected. That hidden nodes are not all connected. They are also selectively connected. This connectivity and the weight of hidden nodes are randomly assigned. They are not assigned with some probability. This time these are connected, next time the other sets are connected. Every time the connection points are changed. On ESN, the final output weights are trainable. The last weights are weights only you have to train and can be updated. It is used for prediction purpose, data mining purpose, classification purpose, etc. So eco-state network is also a modification of RNN. This is a diagram of a eco-state network. Please have a look to the eco-state network. Here, 3 inputs, 2 outputs, and they are randomly dropped. All are not connected. And dropped with certain overfitting problems are avoided. But performance-wise, also they are good. Eco-state network, these R's are, so there is a feedback also, not only dropped, there is a feedback also. It is a feed-forward feedback network with randomly dropped inputs. That network is called eco-state network. So deep residual network with many layers can be tough to train. Take much time for training. Deep residual network prevent degradation of results. Even though they have many layers, with DRN, some parts of the inputs pass to the next layer. Each network can be quite deep. Applications are imitation, object detection, sentiment analysis. This is used mostly for language processing, but first for DSN used for healthcare, finance, and all other engineering application. Most of the application people have been using. So this is deep belief network, deep residual network. This is the architecture of deep residual network. Please have a look. That is RNN type. That from one edge connect to next edge. From this edge, it is not bypassing in between hidden layers. Input is same, output is same, and there is a feedback, recursive feedback. They are not completely taken from each of the unit like conventional RNN. First is connected to third, to fifth to seventh, and so on. This is a deep residual network. The purpose of such network is because of many hidden layers, overfitting problem and vanishing gradient problem, so that it can perform to some satisfaction. Deep residual network. So deep residual neural network with many layers can be top to train. Deep residual network prevent degradation in the result, even though they have many layers. With DRN, some parts of its parts pass to the next layer. Therefore, this network can be quite deep. Application, image classification, object detection, semantic segmentation, language recognition, so natural language processing, and object image classifications, etc. They are used. The last one is neural Turing machine. Turing machine must have heard. So neural Turing machine, it is an architecture. It contains two primary components. Neural network controller. There is a controller and there is a memory bank. These are components of a neural Turing machine. In this neural network, the controller interacts with the external world via the input and output. The controller connects link to input as well as output. It also performs selective read and write operations by interacting with the memory matrix. A Turing machine is said to be computationally equivalent to a modern computer. Therefore, NTN extends to the capability of standard neural network by interacting with external memory. Applications used for robotics, building, and artificial human brain, and many such applications. So neural Turing machine is another issue. So this is about, I gave an overview of the different types of network. This is the architecture of neural Turing machine. As I told, the lower one is the controller, memory cell, and memory cell is connected only to the last layer. The input layer is conventional neural network, but there is a memory cell. Memory cell is connected to all the three memory cells. Each are connected to all the three hidden layers. To the lowest one, all three are connected. The middle one, all three. To the first one, all three. And then final layer output is produced. This is a neural Turing machine, NTM. Of course, is the algorithm is there. How to use, how to train. The training procedure is same, but the architectures are completely different. Each one, new architecture, purpose is different. Basically, things, as I told repeatedly, vanishing gradient problem. I told that both the vanishing gradient and the overfitting problem needs to be rectified, and so that the performance can be obtained. Essentially, what I covered today are at least 20 types of artificial neural network. The first one, I talked of conventional NLP, that is that propagation based learn. Next, what I said, again, I am repeating, I did not teach you, but I told radial basis function, functional being artificial neural network. Then I came to recurrent neural network. And recurrent neural network, LSTM, there are two. LSTM is one of the variation of RNN. Then I talk about net. I talk about GAN. I talked about belief network. I talked about deep belief network, Boltzmann machine, self-organizing map. Then I talk about autoencoder. I talked about CNN. I talked about GAN. I talked about many such neural Turing machines. So at least more than 20 times what exists today. I just make you learn. It is my first lecture and these are there. I have not gone deeper into any of the network. What I essentially taught was the exposure. The most of the later part after RNN and what I taught, there are various variation of deep learning. GAN is deep learning, autoencoder, deep learning, CNN, deep learning. These are all Boltzmann machine. Single unit is there, but it can be multi-layer and that becomes your deep learning. So I covered actually the overview I gave and I told about the different types of structure. Now I request Professor Chakravarti, if anybody interested to ask some question, then perhaps this question I'll try to answer in the next 10 to 15 minutes. Okay?
Yes, sir. Thank you very much, sir. You have really covered the many number of neural network here. A small request from some of my faculty. Yes, sir.
22 types of neural network.
So some of my faculty recently took admission into PhD, and they are very much interested in working in neural networks. The interest in neural networks, it started with your last lecture, sir, in the college, where you have stopped with neural networks.
Hello, sir.
Yes, yes, sir.
Yes, I am talking on behalf of Panda, sir. Please tell the questions I am writing. I will give it to him.
Yeah, sure, sir. Sir, some of my faculty, they are pursuing PhD.
Okay.
Recently took admission in PhD, and the idea of, their interest in your triggered with his lecture, and there was some little interaction with him also. His name is Suresh. What actually he is, it is he has done some literature survey on this biological neural network, that is spiking. He really in good research problem. This signal or image applying this biological spiking neurons. Can you? He is actually asking for some guidance on this. Good research problem.
Okay, sir. I have noted it down. I am just giving it to Panda, sir.
Yeah. And faculty members who are interested to push the queries, they are really welcome. And anybody from students, Srikar or anybody who are members of this comms, are welcome. You can drop a small message or raise your hands. I can unmute you so that you can speak. Whoever in YouTube also following lecture, they can put their message in the chat window, or you can drop a message directly to me so that I can read it out for you. uh, of our college from other departments because students you know how interactive were the last lectures of Ganapati Panda sir in our college when he visited our college for good number of times, especially the last two DVP lectures that he has taken up. So I suggest you to open up and push your queries, or you can unmute, you can raise your hands, unmute you. Yes, now you can actually unmute yourself. Anybody who is interested to speak, you can unmute yourself. Ma'am Sonali, ma'am. Anything in specific also now can push that tomorrow. We can address that. That's the question, Mr. Suresh, as
Okay,
well as
sir.
from.
Okay, sir. I am giving it to
Sir, Prof.
Hello.
Sir.
Yes,
Good afternoon, sir.
I got one nice question for PhD admission, Mr. Suresh.
Yes, sir.
Sir, good afternoon, sir.
Yeah, a spiking neural network is a very important area. Today, there are about 5 models exist. So I request Suresh, there are 5 models, and these models in 2002, I am sending a snapshot. 2002, one model came, how the spike propagates. Spike prop, one model. Model 2, SWAT, SWAT. It was published in 2010. The third model is OSNN, 2014 online spiking neural network. In 2016, SRESN, self-regulating, evolving spiking neural network. And in 2017, Saffron, synaptic efficacy function artificial neural network. So this snapshot I had said you can try to understand. We'll try to make, you can, a lot of application, classification or forecasting can be used for your own antenna array work, where you use SNN. You can develop one chapter, deep learning SNN. Yet SNN, RNN used for deep learning, conventional neural network, LSTM used for deep learning. So can you use SNN as deep learning? If you give many layers, can you solve a large density data problem? So there are two parts. First, let him write a good review paper on SNN. I will help. Let him find out all published literature, at least 30 to 40 literature, write a good review paper. That is the part one. Part two, that at least try to understand one of the 4 models. Saffron is the latest 2017 and Session in 2016. So these two let him learn and use for antenna problem. The third part, we can make a deep learning, spiking neural network. I think it is clear. I'll send you this, yes.
Hello.
Yes, sir.
Yes, sir.
Yes,
Please
sir, I
repeat
will.
your question. I am not clear.
Sir, one more question, sir. Yes, sir. It was really informative, and I hope Suresh, you are now you can you have the basic information.
Okay.
Yes, sir. Yes, sir. Yes, sir. Thank.
There was one more question. Uh, a student, Mr. Srekar. So his question is, can you suggest any beginner level project for related to machine learning? These students, we have a student branch, sir,
Yes.
communication and signal processing societies of IEEE in the college. So there are few enthusiastic students who are working on it. Last year when Panda sir has visited the campus, some projects and some of them have really worked on it. So they were looking for some useful projects that they can pursue in machine learning and signal processing. The two, is specific to this filter, other things or whatever that is possible.
Okay.
This is a
Thank you.
question from Sri.
Just a second. Is he a BTech student?
Yeah, yes, sir.
Okay.
BTech student.
Okay. Okay. Just a second. BTech student from IEEE Students Society. Beginner project.
Yeah. Okay, I'll also help the student, Mr. Sekhar. Are you able to hear me? Sekhar, please, student group. You want to use machine learning is awesome now. And whether is interested in learning or machine learning, if he is in learning, any techniques, unsupervised machine learning, like reinforcement learning. Can he learn reinforcement learning? Can use for antenna? Can he use for healthcare? Can he use for finance, for prediction or classification? There are a lot of problem in communication, cognitive radio. Cognitive radio, if the boy is interested, cognitive radio or your intelligent antenna, adaptive antenna, let him choose a problem where forecasting, let him search problem of forecasting and classification. These are the two important tasks. And random forest he can use. Random forest, net-based, support vector machine. Tell him to learn three things. Support vector machine, SVM. Yes, he can random forest and net-based. If you want me, hello, Professor Chakravarti, if you want me, this one or two algorithm tomorrow, support vector machine, if you want interested in deep learning side or conventional machine learning, reinforcement learning, I can teach tree, I can teach net-based. You want this side or you want on deep learning, tomorrow I can teach RNN and LSTM so that the boy can be benefited. He can apply, he can take a problem of antenna, he can take a problem of cognitive radio, or he can take any problem on image and video processing. First he should select the area, because first area selection, then method selection, and then
Yes, sir. Maybe.
if you want that more of the BTech students are there, they want to learn machine learning, I can teach some machine learning technique instead of deep learning. So you tell me what shall I do tomorrow or day after.
Yes, sir.
Okay,
More of
so we'll discuss and work out, but let the and IEEE student group, nice. Let him use random forest is a powerful technique. Net-based random forest or decision tree, let him learn and apply to smart antenna, apply to, since he's a communication student, he can apply to what smart antenna or communication problem or IoT problem. One of the IoT is an interesting area. Let him find some classification and prediction problem and use this. Is it okay?
Okay, sir.
We can discuss offline and I can suggest exactly what the boy Shekhar has to do. Okay?
Okay, sir.
Okay, thank you. I think it is over.
Yeah.
Chakravarti is over.
Yes, sir. Over, sir.
Okay. So
Yeah.
thank you for giving opportunity.
Yes.
Yes, thank you.
Thank you, sir. Thank
Okay,
you.
Thanks
Thank
a lot.
you.
Tomorrow we'll
Thank-
decide what exactly to be taught based on your input. I'll teach tomorrow from 11:30 to 1:30. Okay?
Thank you, sir. Thank you very much for your support. Uh, we are very fortunate that you are here to teach us, and you have today have given a list of all the. Thank you very much, this DVP, sir. Once again, on behalf of the Department of ECE, Professor P. Satish Ram Chaudhary Garu, Vice Principal and HOD of ECE, and all the staff members of and the IEEE of Raghu Institute of Technology. Thank you very much, sir. Tomorrow I'll come. We'll join once again with you to listen to you once again on machine learning and deep learning topics, sir. Thank you very much, sir. With your permission, I'll end the meeting now.
I also
Thank-
convey my thanks to Satish, to Chakravarti yourself, the principal and the management who gave me an opportunity to interact with 150 participants today. I am extremely happy. Hopefully tomorrow we'll again continue on some particular topic in which I'll speak on details, some more details. I gave an overview only today. Okay? Thank you.
Okay. Thank you, sir. Thank you. Thank you all. Request to join tomorrow exactly at 11:30. Maybe 10 minutes prior to the session would be helpful for us to sort out the things over here. So thank you all the participants and all my colleagues, faculty members, and especially to my vice principal and HOD, Professor P. Satish Ram Chaudhary Garu, for his coming, getting this DVP sanctioned and extended to this year also, so that we have the advantage of having the campus and teaching us. Thank you once again, sir. Bye all. I will meet again tomorrow. I am ending the meeting. However, the session are not there for all students. As usual, we'll 30 and 11:15 will be joining this session until 1:30. So you plan yourself accordingly. Thank you all. Bye.